Okay, guys, so today's assignment was the Padlet for distance versus displacement. So in the top right-hand corner, if you have the select option guy out, okay, you can click on the link and it will open you to this website here that has a bunch of the videos and clips for you to view. After viewing them, you are to answer those questions. So let's just go along and fill out some of these. Let's go to text box. Okay, click in here. I'm gonna have the highlight color be yellow. Okay. So in the first video, if you watch it, we have distance as the measure of length between 2 points. And then the overall change of position, we're going to call displacement. So displacement is a really like how far you are from where you started and then in what direction, like north, south, east, west, positive or negative, left, right, up, down. Now, displacement is a vector, so that is why it needs that direction. Distance is not. Distance is a scalar quantity. So then in this piece here, it asks you to draw and label arrows on the image to show the distance completed and then to show the displacement. So what you would do is you can use drawing, but to have nicer lines, I would go to shapes, guys, click on insert line. I'm gonna make sure it's on black here. Okay. So in the video, they go first from A to B. So you're gonna have a one line here. Make two little wings for my arrow. And then they turn around and went back to this 50-meter mark. So the total distance traveled, if you go 100 meters one way and then 50 meters back the other, how far did you fully move? Well, the distance there is going to be a total of 150 meters. Okay, and then they asked you specifically about the displacement. Displacement doesn't care about all the motion that you've done. It just cares about pretty much where you're at, where you finished versus where you started. So you started at A, you finished here at this 50-meter mark. Boom. So there's your vector there for displacement. And so when we have our text box here, how far are we from A? Well, we're 50 meters. Now we need to give it a direction: positive, negative, left, right, up, down, north, south, east, west. And again, if you watch the video, they're saying that east is over here to this direction. So we are going to say east. In the second video, the blue dot that goes moving around. So the blue dot goes around this red path, all squiggly wiggly. That is the total distance that this thing actually travels. That is the total distance that the thing actually travels. And then they show a line from point A to point B, a straight line representing the displacement of the object. So the blue dot on red line is going to be our distance. So I'm going to go to click on shapes again, go to insert ellipse, and I'm going to just boom, right over that. Okay, the black line was supposed to represent displacement. Click on that, bam, done. So in this animation, what is the distance covered by the ball? Okay, so for this one, all right, you see the ball going this direction, going up, doing this whole little slide thing, and ends here. So it tells us that the distance is 30 meters total and that the displacement was 0. So in this animation, what is the distance covered by ball? Well, that distance, guys, was 30 meters in total. What about the displacement? Well, you finished where you started, so the displacement here is 0 meters. And a question I get is, well, what if you finish back where you started? Okay, I get that it's 0, but what do I put for direction? If that is the case, if you do end on 0, then you do not require a direction. So in the video, or what they're asking here is to trace the overall distance. So for this one, I'm going to go to drawing. I'm going to go to drawing, and then I'm going to go to this green color here. Because in the video, it shows that the path as this thing takes kind of comes up, goes down like a slide, kind of curves back up a little bit, and then comes all the way back down. So it started here on this little X, it went to the right, went up, and did something along those lines. Okay, so there we go. We traced the distance. Now circle the displacement. So the color of the circle here was blue, so I'm gonna make this one blue as well. So the very beginning, all right, I'm going to put a ball here up. Crap. I want to actually change that so it fills in. So what I'm going to do is, if I scroll up here to where it says stroke thickness, normally keep it on 1 for all your lines and all that. But if I want to fill in one of these shapes, I can hit fill. So I'm going to just kind of redo this. Boom. So it looks like that. Okay. Now in the next clip, all right, that there is to watch, it's a scene from The Matrix Reloaded. It's a cool clip. We're not doing it in crazy detail because in here Trinity is weaving in and out of cars and everything like that. She tries going around the outside, the truck cuts her off, so she has to turn around, and then again is driving back and forth through traffic. Okay, and then lands pretty much here where Morpheus saves the keymaker. And okay, all that. If we had to try and figure out all of that distance, that would be a real pain in the butt. So what we're going to do is say, all right, we're going to start here at the bottom of that star. See now, look how thick that line is. No good. So I'm going to go to the undo up here, and I'm going to go back up here to stroke thickness and go down to 1. I'm going to change my color to red as well. So I told you guys in class to start here from the bottom of the star as our starting point. So, and you're going to go up until the truck cuts you off, which is on this line here. So Trinity goes upward to the truck. That's her first part. And then I'm going to say to stop right about there. All right, on that dashed line. So it's whole numbers, it's easier to view and to get our actual answers. And then afterwards, she decides to go backwards to try and get this guy out of there, save him, and goes towards Morpheus. All right, add these little pieces here for our vectors. So they ask you, okay, count the number of squares to calculate the total number to calculate the total distance. Now, the unit that they're telling us everything is in squares. So, okay, we're just figuring out what the magnitude is then. So if we start here, you go 1 box, 2 box, 3 boxes, 4, 5. So we have 5 squares going this direction, and then we come back 1, 2, 3, 4, 5, 6, 7, 8 squares. Okay, so the total distance would be the added values together. Now, when we do this, the direction doesn't matter when you're calculating distance. So yes, even though they're in opposite directions, for calculating total distance, that is okay. We're not worried about that. So we're going to just add the values together. 8 and 5, we're going to get 13 squares as our distance. Now the displacement. Change in position. How far you are from where you started. So we finished, all right, we finished down here. How far is that from the starting position? Well, you're 1 box or square, 2 squares, 3 squares. Okay, so we're 3, but we have to indicate a direction. So on certain graphs, all right, you can add a negative sign, and that will equal a direction. So we could say that, all right, and I said this in class, that going above this position, we would say positive, and then below would be negative. So we are 3 squares below, so what we would write in here is a negative 3 squares. Now again, our normal units, guys, are going to be meters or something along those lines. So, but negative 3 squares. All right. Okay, and then the last one is a clip from the Fast and the Furious. Again, they're bobbing and weaving throughout all this kind of stuff. And I said in class to start right there. Pretty much on that X. Okay, go up to that point here, and then to stop your second vector where they crash. So I'm going to show those in red. So we start here. We're going to go up. And then from there, we're going to go over. Now, those are going to be our vectors. So add my little lines here for my arrows. Okay. How many boxes did we go up? We went 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 squares again. And then over here we got 1, 2, 3, 4, 5. Okay. Now we got 5 squares. Okay, so count the number total distance. Again, 8 and 5, when you add them together, that's going to give us a total of 13 squares. Now, I asked you to do this in class. Draw an arrow to represent the displacement. So, again, to shapes, line, I did this in black, going from the starting point all the way to the end point. Okay, that would represent our displacement, a straight line distance from where you started to where you ended. All right, good. Now, I also specifically asked you guys to use or to calculate the value for the displacement, calculate the magnitude. And remember, when you have a net y direction, like up or down, and a net x direction, like left or right, you cannot add or subtract those. In that case, then you have to use the Pythagorean theorem, and we rearrange it so it's that it equals c is equal to a squared plus our b squared, and we have to square root that whole thing. So again, on this, you can't really do that, so we're just going to go yeet, use a drawing tool there to give us our little line. So we have our values 8 and 5. So we're going to have 8 squared plus our 5 squared. Oop. All right, I can type good. And what do I do with that? Oh, don't forget that I also need to square root it. Okay, so 8 squared plus 5 squared is going to be 89, and then we take the square root of that and round it to 2 decimals. Now that is going to kick out an answer of 9.4333. All right, round it 2 decimals. We'll call it 9.44 or 9.43. The unit that they're giving us here is squares, which is annoying. And then give a direction. So, if you have something up and right, we could say that up is north, down is south, right is east, and west is left, unless they give us something else specifically. So since we have a vector going north and to the east, we would say this is northeast to be your final answer here. Bam. Nope. One of that, one of this. There you go. Nice. All right, guys, and then you can file. All right, you can save it and then submit. Um, some people were having trouble. If you guys then click download, right, not computer, but your Google Drive, you can begin export. It will save to your Google Drive, and then when you go into, all right, classwork, um, and you select, all right, view assignment, you will be able to, all right, turn it in. There should be a thing over here where you can add an attachment. All right, and add the attachment, and then submit. Now, if you want to make sure, if you click on the attachment, just make sure that your edits came up. Now, sometimes it takes a second or two, so it may show a blanket right up first, but if you give it a second, you should see your all your edits. Okay. All right, guys.